So what we're going to have a look at today is index laws. Now this is a little bit of an extension in year 8, but it does set you up very nicely for some of the more complicated components of algebra that comes up in year 9 and year 10. So we're going to introduce today the 4 more simple rules or index laws. So if we have a look at the first one, when multiplying powers with the same base, we add the powers. Now when we are talking about the same base, what we're talking about, okay, is the same bottom number. So if you look at the example, a to the power of m times a to the power of n equals a m plus n. Now we're plussing them because we're timesing the bases together, and this corresponds to the first law. When multiplying powers with the same base, we add the powers. Now we've got a bit of an example here to show you kind of what that means without all of these letters to make it less complicated. So we're going to write this out in its expanded form. So 5 times 5 times 5 times 5 times, now 3 5s, times 5 times 5. So we've got all the same base, okay, so what we can actually do is go 5 and then 1, 2, 3, 4, 5, 6, 7. 5 to the power of 7. Now in algebra, sometimes we don't know this base, like when we have 8s. And in this case, when this happens, we have a to the power of 4 times a to the power of 3. Now it's still the same thing, like this, but we can shorten it up. Knowing the rule, we simply plus the two powers together. So 4 plus 3 equals 7, which is what we've got over here. Okay, so that's kind of what it does, it means in its expanded form. But we can do it in a much quicker way by simply adding the two powers together. Our second law, when dividing powers with the same base, we subtract the powers. So again, a to the power of m divided by a to the power of n equals a to the power of m over a to the power of n, and this will equal a to the power of m take away n. We're subtracting it because there is a division sign. So again, we've got an example here to show you kind of what that means in the expanded form. So we've got 5 times 5 times 5 times 5 times 5 times 5 over times 5 times 5 times 5. Now these cancel each other out, okay? If I divide the 5 by the 5 on the bottom, it's dividing by itself, which is equaling 1, and as we know from previous videos, that actually cancels itself out. So cross out, cross out, cross out, and cross out. So I am left with 5 as the base still, to the power of 2, because I've got 2 5s left, and we're timesing it by itself. So 5 to the power of 2. Now what this looks like using our algebra, a to the power of 6 divided by a to the power of 4, okay, we're subtracting the 6 from the 4. 6 take away 4 is 2, a to the power of 2, okay, exactly like that. Now our third, when raising a term with a power to another power, we multiply the powers. Now there's a lot of powers, this is a very confusing one. It doesn't read correctly. The simplest way is to look at an example. So when we're talking about a power to a power, we've got a bracket a to the power of m, and we're timing this whole term to another power up here. So whenever you see something like this, what we're going to do is actually multiply the m and the n. So again, we're going to have a look in its expanded form. So we've got 5 times 5 times 5. That is one group. Okay. Now we've actually got 4 groups of this. Now what we can do using this is count up how many bases we have. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So we've got 5 to the power of 12. Now, if we didn't know the base, okay, we could write it out. A to the power of 3, okay, brackets to the power of 4. Now we know, okay, from this we multiply these two powers. A, 3 times 4 is 12. So we could do this, okay, and get the right answer, but the much quicker way is to use this law to our advantage and understand that in this case we would times the 3 and the 4 together to get 12. Okay, it's a much shorter way. The last one's very easy. Any number raised to the power of 0 equals 1. Okay, so this term would always equal 1. Something like d to the power of 0 equals 1. Okay, let's move on to some examples of how to apply the index laws. So if we have a look at the first one, so p to the power of 6 times p to the power of 2. Now what does this mean in terms of algebra? Well, p times p times p times p times p times p. Now we're timesing it by p to the power of 2. So all in all, we have got 1, 2, 3, 4, 5, 6, 7, 8. We are timesing p by itself, so this is the same base. Remember, the index laws each say same base, okay? So we have to double check, is this the same base? It is. So we would write p to the power of 8. Now we don't always have to write this out. What we can do, p to the power of 6 plus 2, okay, 6 plus 2 equals p to the power of 8. Okay, this second part is a lot easier to do rather than writing this all out, particularly when we're getting up with numbers like 12. So coming over to the next example, it's a little bit more complicated, but not by much. Now you notice that these parts, okay, are the same. They have the same pronumeral, okay, which is good. What we do, however, with these numbers is we start with them first. 3 times 7. So we know that 3 times 7 is 21. M to the power of 2 times m to the power of 3. So what we're doing, okay, is plussing these two items together because it is multiplication. So m, 2 plus 3 is 5. Then we come, now whenever it has n and we don't have a number up there, we assume that's to 1. N to the power of 1 times n to the power of 5. So again, we're going to write n. 1 plus 5 equals 6. So just remember that whenever you just see a pronumeral on its own, it's always to the power of 1. Now, going on to our second index law. We've got a, now we've got 12, a to the power of 12 divided by a to the power of 4. Now we know with division, okay, what that means for the index laws is that it is actually subtraction. So 12 take away 4. So a, 12 take away 4 equals 8. Okay, that's our answer. Now with this, again, we've brought numbers into it. 42 divided by 7. So we know that that is 6. Y to the power of 6 divided by y to the power of 2. So we write y. 6 take away 2, that's 4. And that is our answer. Coming down here, our third index law. So d to the power of 4 to the power of 5. So whenever we've got these brackets, we're multiplying. So d 4 times 5. So d equals, that equals d to the power of 20. Why 20? 4 times 5 equals 20. Now this would work out completely the same if we did it in the expanded form, it would just take a lot longer. Now, 4 to the power of 3. Okay, so we come over here, 4. Now, see that button right there? Okay, x to the power of square. Press that, and then put 3. Okay, that's timesing 4 by 4 by 4. So 64 m. Now 2 times 3 equals 6. That is our answer. Down here. Now it's easier to look at this in the expanded form. Okay, because this is going to make a little bit more sense. Now, any pronumeral to the power of 0 equals 1. So what this is really saying is 2 times 1, that equals 2. Coming over here, okay, we've got 2k brackets, okay, to the power of 0. Now, anything to the power of 0 equals 1. So the 2 is actually separated from this pronumeral, okay, which is making this 2 times 1. Over here, it's actually associated with it in terms of these brackets, which makes this whole term to the power of 0, which makes this whole term equal 1. Okay, so you just got to remember, if you see it without the brackets, it's going to be something times 1. If you see it in the brackets, like this, the whole thing is going to equal 1.